Assalamualaikum and hello everyone. Welcome to our presentation on the topic of techniques of integration. Today, we will explore some of the fundamental methods in integration and their applications in calculus. Before we begin, let me introduce our team members. The first one is Patty Teresi Anak Lawrence, Grace Kosturgun, Nur Kristina Amira, Nur Alia Maisara, and the last one is Fatty Ilyazwani. Integration is a cornerstone of calculus, and there are several methods to evaluate integrals. The common techniques of integration is integration by parts, integrating trigonometric functions, trigonometric substitution, and the last one is integrating rational functions by partial fractions. However, in this presentation, we will focus on explaining two methods in detail. The first one is trigonometric substitution and integration by parts. By the end of this presentation, you will be able to recognize when to apply trigonometric substitution and integration by parts techniques. And the next one is, you will be able to understand the step-by-step process to solve integrals using these methods through examples. Now, let's dive into trigonometric substitution, a powerful method to solve integrals involving square roots of quadratic expression. Now, let me explain about the method of trigonometric substitution. This idea is to replace the variable with a trigonometric function, transforming the square root into a simpler trigonometric expression. Here is the step-by-step of trigonometric substitution method. The first one is identify the quadratic expression. Determine the form of the square root expression. To start, we will be concerned with integrals that contain expressions of the form square root of a squared minus b squared times x squared, square root of b squared times x squared minus a squared, and the last one is square root of a squared plus b squared times x squared, in which a and b is a positive constant. The next step is to choose the appropriate substitution. For square root of a squared minus b squared times x squared, use x equals to a over b sine theta. And the next one is for square root of b squared times x squared minus a squared, use x equals to a over b secant theta. And the last one is for square root of a squared plus b squared times x squared, use x equals to a over b tangent theta. The third step is to transform the integral. Substitute x with the chosen trigonometric function. The substitution will simplify the square root into a trigonometric function. Change the differential dx into a cos theta based on the substitution. The next step is simplify the trigonometric expression. Use trigonometric identities to simplify the integral. Cosine squared theta equals to 1 minus sine squared theta. Next one is tangent squared theta equals to secant squared theta minus 1. And the last one is secant squared theta equals to 1 plus tangent squared theta. And the last step is integrate. Solve the integral in terms of theta. Use standard trigonometric integrals where applicable. After integrating, convert back to the original variable x using the relationship between theta, x, and a and b. Before we start the calculation, the first step is to determine the form of the equation. As we can see from the question, square root of 9 minus 4x squared is the same as square root of a squared minus b squared times x squared. From square root of 9 minus 4x squared, we can find the value of a and b. From this, we know that the value of a is 3 and b is 2. From this, we can find the value of x. From the equation, x equals to a over b sine theta. So we get the value of x is x equals to 3 over 2 sine theta. From the value of x, we can find the differentiation dx over d theta equals to 3 over 2 cos theta, and dx is 3 over 2 cos theta d theta. Next, from square root of 9 minus 4x squared, we can simplify this equation and insert the x value. We insert the x value in here, square root of 9 times 1 minus sine squared theta. 1 minus sine squared theta is the trigo identity. Cos squared theta equals to 1 minus sine squared theta. So, from this we get 3 cos theta. The next step is evaluate the integral of square root of 9 minus 4x squared over x dx. We insert the dx value here. The dx value we insert in this. We can eliminate 3 over 2. And here we got the integral of 3 cosine square theta over sin theta d theta. Cosine square theta, this is the trigonometry identity. So we put 1 minus sin square theta, and then the constant we put in front of the integral. So 1 over sin theta is the cosecant theta equals to 1 over sin theta. We eliminate the sin theta and we got 3 times integral of cosecant theta d theta minus integral of sin theta d theta. After we integrate this, we get 3 ln cosecant theta minus cotangent theta plus 3 cosine theta plus c. From this triangle, we can get the cosecant theta. The cosecant theta equals to 3 over 2x. Cotangent theta is square root of 9 minus 4x squared over 2x, and cosine theta is square root of 9 minus 4x squared over 3, and the final answer we get 3 ln 3 minus square root of 9 minus 4x squared over 2x plus square root of 9 minus 4x squared plus c.
Hello everyone, my name is Betty Teresi Anak Lawrence, and now I will continue with 2 sample questions involving trigonometric substitutions topic. So we will start our discussion on solving 2 sample questions that related to trigonometric substitution topic. But before we go to the questions, we need to understand about this equation or 3 cases here in trigonometric substitution table, where I'm sure it will help us to solve the questions that related to trigonometric substitution later. Okay, so let's continue with question 1. So the question asks us to evaluate integral 1 over x squared, square root x squared plus 4 dx. Before we start the calculation, the first step is to determine the form of the equation. So as we all can see here, the equation square root x squared plus 4 is the same as the second case here, which is square root x squared plus x squared. So from here, we can consider the value of x is equal to 2 tangent theta. And the next step, we have to derive it in terms of theta. So we got 2 secant squared theta, and the dx value will be equal to 2 secant squared theta d theta. So this is the next step where we substitute the value of x and dx into the question earlier. And here you can see the red handwriting showing the substitution of x and dx values. We calculate and develop the equation as usual. After that, here we can see that there are 1 plus tangent theta here. This is an identity as was stated in the table earlier. 1 plus tangent theta is equal to secant squared theta. So we can change the value here, make it same here, and we can cancel it out. So finally we got integral secant theta over 4 tangent squared theta d theta. Because 1 over 4 is a constant, so we can put it in front and we can focus on solving the integration of secant theta over tangent squared theta d theta. But before that, we can change it secant theta, change it to 1 over cos theta, and tangent theta is equal to sin theta over cos theta. So we can change it into this form. And next, here we will multiply the numerator by the reciprocal of the denominator here, and it can be cancelled out like this. Then we got this 1 over 4 integral cos theta over sin squared theta d theta. From here, we have to do another substitution. So let's start. We let u equal to sin theta and du equal to cos theta d theta. So we can write it like this: 1 over 4 integral du over u square. We integrate du over u square and it will turn out like this, which is 1 over 4 multiplied with negative 1 over u, and don't forget about c. We substitute the u value back and we got 1 over 4 sin theta plus c. 1 over sin theta is cosecant theta, and we can write it in simplest form like this, which is negative 1 over 4 cosecant theta plus c. So from here we can draw the right angle triangle from the x value earlier, which is x equal to 2 tangent theta, and we got the value of tangent theta is equal to x over 2. This value will help us to determine the sides value of the triangle. So cosecant theta is equal to hypotenuse over opposite, and we can write it as cosecant theta equal to square root x squared plus 4 over x. We can substitute it back into the equation, multiply it with negative 1 over 4. So finally we got the answer, which is negative square root x squared plus 4 over 4x plus c. So this is the final answer for question 1. Next is question 2. The question asks us the same thing, but it is just the question given is different, which is square root x squared minus 1. For the first step, we will do the same thing, determine the form of the equation. And here, as we can see, that we can use the third case here, which is square root x squared minus a squared. So we can easily determine the x value, which is x equal to 1 secant theta, make the derivations equal to secant theta tangent theta, and the dx value is secant theta tangent theta d theta. Here is the next step. Substitute the value of x and dx as this red handwriting here. So first, we already saw that secant squared theta minus 1 here. This is an identity based on the trigonometric substitution table earlier. So secant squared theta minus 1 is equal to tangent squared theta. So we rewrite it back here. We can cancel the square root n squared. Make it keep in the simplest form, and we got integral 1 over secant theta d theta. Then we have to change secant theta into 1 over cos theta. So the simplest form will be integral cos theta d theta. And then we can integrate cos theta just like usual, which is integrate cos theta will be equal to sin theta plus c. So from here, we draw the right angle triangle from the x value earlier, which is x equal to 1 secant theta, and secant theta is equal to x over 1. We can determine the value of the sides, and next we already know that sin theta is equal to opposite over hypotenuse. So we can write it like this, which is sin theta equal to square root x squared minus 1 over x, and substitute it back into the equation earlier. Finally, we got the answer, which is square root x squared minus 1 over x plus c. So here is the final answer for question 2, and that's all from me. Thank you for all your attention.
Hello, my name is Feti Eliaswani, and I will continue with topic product rule and integration by part.
The next topic, which is product rule and integration by part. So, first we need to know what is product rule. Product rule is a method to find the derivative or differentiation of a function given in the form of the product of two differentiable functions. So this is the formula that we'll use, so we need to remember and understand this formula. Okay, then we'll move to the repeated integration by part. Repeated integration by part is a calculus technique used to find the antiderivative of product of function that requires multiply integration application. To the next part, which is tabular integration by part. Tabular integration is a tabular method or table method or DI method, which is D is differentiation and I is integration method. Tabular integration is a shortcut method for repeatedly integrating by part. So this is the fourth question. So we'll use the tabular method. So we will have a box like this, and for here it was a repeated differentiation, and here repeated integration, and in the center is a sign positive negative. So just in the differentiation box, just do the differentiation. You need to differentiate the value of u, which is x squared. So differentiate it until it gets the value 0. For integration, we need to do the integration. We need to integrate the dv function until it gets 0. When the u value gets the u value gets 0, then it will stop here. So just insert back the value and we'll get the final answer. So the next part is integration by parts. So this is the formula we'll use. So this is the last question. This is the formula, and just categorize, insert the value in the formula. So this is the solution. Make sure you won't do any mistake, because when you do any mistake in any part here or maybe here, you won't get the final correct answer. Okay, so that's all from me. Thank you.
Hi and Assalamualaikum. My name is Nur Alia Masarah binti Jukiman, and I will explain the guideline for integration by part like that and answer the question.
Integration by part. So for the guideline for integration by part, we use acronym LATET, which is logarithm, inverse trigonometry, algebraic trigonometry, and exponential. Why we have guideline for integration? It is because when we want to do integration by part, we must know which one comes first. Logarithm is number 1, then inverse trigonometrics number 2, algebraic number 3, trigonometric number 4, and exponential is the last one.
We will be using this formula.
For the example 1 is integrate s e to the power s ds. So if you can see, I already made it. So as we know, s is algebraic and e to the power s is exponential. So s will become u and e to the power s will become dv. So you differentiate for u equal to s du over dx, 1 du equal to ds. So integrate dv equal to e to the power s, v equal to e to the power x. So we use the formula, you write the formula, then you write the equation here, and u multiplied by e to the power x, then es multiplied by dx. Integrate, don't forget, then you can get this answer, and plus c, don't forget. For the question is, this question is repeated integration, which means you're not doing one integration by part but 2 times. So this question is integrate x squared cos x dx. So we can see x squared is algebraic, so it comes first, then trigonometry. So we differentiate u equal to x squared du over ds equal to 2s du equal to 2s dx. So integrate dv equal to cos x, and then we got v equal to sin x. So we using the same formula, which is u dv equal to uv minus integrate v du. So you write down the question, then you can see u equal to x squared multiplied by sin x minus integrate sin x multiplied by 2x dx. So you write down the question, x squared multiplied sin x, and then you can see we have to make the integration by part again. So to be easy, you remove 2 to the infine, and then you can get integrate s sin x dx. So s and sin x, which one comes first is algebraic. So we'll differentiate u equal to x du over dx equal to 1 du is dx. Integrate dv equal to sin x. So when you integrate, you got minus cos x. So you will using the same formula as this, and then put inside here. Write down again, and then s u, this u multiplied by s, and then we integrate, don't forget, v du. So we write again, and then you got here s multiplied by minus cos s plus, you can see minus become positive, and then as we know, when integrate again, minus cos x will become sin x, and then you got the answer, and plus c, don't forget.
Hi, my name is Rizko Sihun. My metric number is D2023110760. Next, I will explain about our second example of integration by part. So we are moving to our second example, integral ln x dx. By using the formula, we can easily determine the value of u and dv. The value of u is equal to ln x, meanwhile the value of dv is equal to dx. We can find the value from the equation. Before we continue our another step, we need to find the value of du and v. We're using differentiation to find our du, which is we need to differentiate ln x, and we got 1 over x dx as the value of du. For finding the value of v, we need to integrate dx, and we got x. Now we can substitute the old value that we found into the formula. Ln x times x minus integral x times 1 over x dx. X times 1 over x is equal to 1. So in the second step, we need to integrate 1 dx. And we found that the final answer is x times ln x minus x plus c. That's all from us. Thank you for watching this video. Hopefully you guys can understand this topic well, and see you guys in the next video. Bye bye!